This video is about the tangent graph. So unlike sine and cosine, where you're expected to be able to graph given an equation, for tangent, you're just supposed to be able to identify the graph and answer some questions about the graph and about the characteristics of the graph. So here is what tangent looks like. Tangent is very different than sine and cosine, as you can see. There are multiple curves which make up the tangent graph. So here is one curve. Here's another curve, and so on. What's in between those curves are dashed lines. And those dashed lines are called asymptotes. An asymptote is a straight line approached by a given curve as one of the variables in the equation of the curve approaches infinity. So this is your asymptote. If you go on to take some upper level math courses, what an asymptote is and how it functions is a little bit different, but for this course, all we need to know is it's something that you approach, but you never touch. And we'll see asymptotes with tangent, and then we'll see asymptotes later on with some other functions as well. So you'll become familiar with an asymptote more and more throughout the year. So like I said, there's going to be some questions about characteristics of our tangent graph. So let's go through some basic information here. Amplitude, remember, in a formula is half your max minus your min. But if you notice, there are arrows on the ends of my graph. So this graph of tangent approaches infinity and negative infinity, meaning there's no maximum and there's no minimum. So if there's no maximum and no minimum, there's also no amplitude. Period, remember, is the length of time to see one curve. So here is one curve. It's going from negative pi over 2 to pi over 2. So this distance from here to here is the period of tangent, which is pi. My domain, remember, are your x values. So that's from left to right. And your range are your y values, which are from bottom to top. So my domain is all of my x values except my asymptotes. So except negative 3 pi over 2, negative pi over 2, and so on, which actually, if we go back, I think there was a question at the bottom here that we didn't answer. Yes, it says, where are your asymptotes located for tangent? So we just said negative 3 pi over 2, which remember is negative 270 degrees, negative pi over 2, which is negative 90 degrees, positive pi over 2, which is a positive 90 degrees, and 3 pi over 2, which is a positive 270 degrees. And your asymptotes are going to continue infinitely in either direction, but these are just examples of them. So my domain is really all values except asymptotes. Now my range, we said, was the y values, and that's bottom to top. And as we talked about with amplitude, your range or your arrows on your graph point from bottom to top. They go on forever. So my range is all real numbers, which in symbols is negative infinity to positive infinity. And then our increasing and our decreasing intervals. Remember, increasing means that from left to right, my graph goes up. Decreasing means that from left to right, my graph goes down. So you should notice, hopefully, that there are no decreasing intervals. My graph is constantly increasing. Where is it increasing from? Well, it's increasing in between my asymptotes. So from negative 3 pi over 2 to negative pi over 2. Also from negative pi over 2 to pi over 2. Also from pi over 2 to 3 pi over 2. And it's going to continue over and over and over again. Because just like sine and cosine, the one thing that they do have in common is that it's a repeating pattern. So even though I'm only showing you a snapshot of the graph, this is the same thing that would continue if I extended my graph or my x-axis in either direction. So in other words, this is in between the asymptotes. So these are our characteristics of our tangent graph. So let's take a look at an example of what a question would look like. As x increases from pi over 2 to 3 pi over 2, the graph of the equation y equals tangent x will increase from 0 to 1, decrease from 0 to negative 1, increase without limit, or decrease without limit. So tangent, remember, never decreases. So I'm going to get rid of choice 4 and choice 2. Now, I have a picture of the graph up here. If you didn't, you would just sketch a little picture. That's why it's important that even though you don't graph perfectly, you are able to sketch a picture of the tangent function. They're specifically talking about x going from pi over 2 to 3 pi over 2. So that's from here to here. So my graph is going from here all the way up. It is increasing without limit. There's an arrow on the end. It is not stopping at 1. So these are the types of questions that you might see for tangent.